Welcome to our first webinar series, everyone. Thank you for joining us for today's webinar. My name is Jana, and I'm the Digital Marketing Manager at MacStadium. MacStadium is the leading provider of Mac infrastructure as a service. Today, we are discussing creating macOS build infrastructure in the cloud, presented by Sean Langton. Just a little housekeeping before we get started. If you have any questions during the presentation, please type them into the question box in your GoToWebinar control panel. I'll bring them up towards the end of the presentation. Now, without further ado, we'll turn it over to Sean Langton. Our presenter today is the Chief Revenue Officer at MacStadium.
Great, thank you very much, Jana. So welcome everybody. We'll give just a couple of minutes for folks to file in, but I'll give a quick introduction of myself. I'm trained as an engineer, have experience with startups and enterprises. Currently, I'm leading sales and marketing at MacStadium, and today we're going to spend some time sharing lessons learned from some of the hundreds of DevOps teams that we work with. So to get started, I'm going to share a little bit about who this talk is for. Hopefully, you're in the world of iOS and macOS app development, either an iOS developer or a macOS developer or one of the DevOps engineers that supports those teams. If that's not you, I might get a little bit over your head with some of the acronyms and technical topics we dive into, but there's lots to learn at the macstadium.com website where you can follow up on all kinds of additional details. So what are we going to cover today? We'll touch on a few topics. We'll start with a brief recap of why macOS is required and how it fits into the Mac CI process. Then we'll get into several different options for running builds and talk through some of the top challenges that we've seen iOS and macOS CI setups face. Finally, we'll wrap up with some Q&A and point you guys to where you can learn more. So to get started, hopefully this concept is familiar to most of you on the call. Continuous integration and deployment, or CI/CD, is a development paradigm that's been taking hold lately. This process is big and meaty and has lots of debate within it. We couldn't possibly hope to cover all of it on this call, so what we're going to really focus on is the build and test component of continuous integration, or CI. At a very high level, continuous integration means that you're going to build on every commit, you're going to test on every build. It helps development teams catch errors faster and reduces the overall time to value. So how does CI work everywhere except for Apple World? You commit your code to your Git repo, wherever that lives. That'll kick off your CI tool to start automating a build job. You use some infrastructure as code tools to prepare your infrastructure, provision it from a public cloud or some kind of internal resource, spin up a container that has all of your build artifacts, run your build, blow the container away, and there you have it. It's simple, it's scalable, it's immutable, and while there are thousands of variations and lots of different ways to do this, this is a pretty agreed upon process that works really well. In Apple World, it's not so simple. First of all, you need Xcode to run any builds or tests for iOS or Mac apps. Now, Xcode only runs on macOS. macOS only runs on genuine Apple hardware. And you won't find any Mac infrastructure on public clouds like AWS, Azure, or Google Cloud, because it's just too difficult to set up and run. There's actually a lot of expertise that goes into doing this well. You'll also find that macOS doesn't support containers, which means that you'll need to use VMs. Apple really asks its developers to build different. So, given all of that, what are your options? Well, there's a few. The first option, and it's a great option, especially when you're starting out, is to use a CI as a service provider. Now, We're huge fans of these tools. Actually, most of these CI as a service providers use MacStadium infrastructure under the hood to power their Mac builds. So we're big fans. However, there are a few reasons why you may not want to use one of these tools. The flexibility is limited. For example, let's say you use another CI tool like Jenkins or BuildKite or TeamCity. That's not going to be compatible. You may also need to do more customization of your build environments. These services don't give you access to the underlying infrastructure, so you're stuck using whatever you get. You may want faster builds. With these build tools, the performance is often set by the provider, and it's hard to tweak settings to accelerate and get the full build speed that you might otherwise be capable of. On the security front, even though the security is actually really good on these services, your InfoSec team may or may not be willing to trust these providers with your source code. And finally, maybe you just don't want to pay for CI as a service, especially as your build volume starts to grow. Okay, what's the second option? Most people, because of some of these issues that we just went over, end up going with option number 2, which is to build a DIY Mac cluster. Now, depending on your needs, this might be under a desk, on a shelf next to your office router, in a closet, or maybe even built out in a data center. We've talked to lots of teams that build these and manage them, from everything from a single Mac Mini to actually really impressive scaled out environments. But 100% of the time, it's a challenge, and there's a few reasons why that is. First of all, nobody manages servers anymore. It's a very 90s thing to do. People want to abstract that out to a third-party provider. The reason why is because of scalability. It's almost impossible to scale this. Even people whose job it is to maintain data centers don't know how to manage Macs. Macs are actually consumer hardware, and we'll get into a little bit of the challenge that poses. Additionally, running maintenance on these can be a real hassle. If this is your job, you might be the one who spends an afternoon updating, re-imaging, patching builders, and you might have to do that every couple of weeks. Finally, most customers that we see moving from a DIY Mac solution are running bare metal build servers in their internal environment. This makes it really hard to automate your CI pipeline. And finally, if there's a power failure or if the internet goes down in the closet where these Macs are kept, your development stops. So availability is really important. So what's the third option? Of course, to go with the best and work with MacStadium. And we'll talk about how we do this and solve some of these issues in just a minute. So I've given a brief overview of why it's important to have macOS infrastructure if you're building an iOS app, and what are some of the challenges that customers will typically face. Over the next 20, 25 minutes, I want to share with you some insights that we've gotten from working with some of the best out there. We work with CI leaders that really push us forward and keep us on the leading edge. We work with big brands like Box and Capital One that are well-respected tech leaders that run huge workloads where security is paramount to their performance. And we work with a lot of CI as a service providers, as I said, folks like Travis CI that run at super scale to support their growing user base. And we've learned some lessons from each of these guys, and that's what I want to share with you. Overall, though, we've got more than 3,500 customers worldwide, and that number continues to grow. So what are those top challenges for Macs? There's 4 that I want to touch on here today. First of all, deploying the Mac hardware. It's tricky. Secondly, once you've got your hardware deployed, how do you virtualize macOS on top of that to get more container-like performance? Once you're there, you can start looking at how to automate the pipeline. And finally, once you've got everything built, a lot of people are really doing this so that they can speed up their builds. So let's jump into it. First up, deploying Mac hardware. Now, as we said, this can be tricky, and we've seen this done in all kinds of crazy ways. Fortunately, the answer is simple. Call MacStadium. It's what we do. We do this all day, every day, and we've gotten really good at it. Let me just take a few minutes to talk about how we do this, because I think it's really interesting. At MacStadium, we transform Apple's consumer products, Mac Pros, Mac Minis, and even the iMac Pro, into scalable enterprise-class Mac infrastructure. Our patented technology lets us put these Mac computers into standard enterprise racks. We put them in state-of-the-art data centers, and we have proprietary upgrades to turn these from consumer electronics into real enterprise servers. We add redundancy to the power and to the I/O ports. We add 10 gigabit Ethernet, which is 10 times faster than what the Mac Pros ship with. We add fiber channels so that you can connect to high-speed SAN, which really improves build performance. And all of this is deployed with Mac experts who understand how private clouds work in these configurations, and with 24/7 expert support. So it's not your job or your DevOps guy's job at 2 in the morning if something breaks to fix it. Additionally, we deploy these in private clouds. Small diagram over here on the screen. A private cloud is a little bit different than what you'll find at an AWS or an Azure. In a private cloud, you actually have root access to every piece of infrastructure. You can control the firewall, the Mac hosts, the hypervisor, the SAN array, all of it. And while that may not mean much to you, your security team is going to love this. MacStadium can essentially become an extension of your local infrastructure. And MacStadium is also going to be loved by your security team because of our compliance. We have ISO 27001 and 2, as well as SOC 1 and 2 compliance. And if those don't mean a lot to you, they'll mean a lot to your security team. Okay, so that's how we deploy at MacStadium, and my advice is to leave it to us. You'll really save yourself a lot of headache. Problem number 2 is how to virtualize macOS. Now, as I said, containers don't really run in a high-performance way on Macs, and so you're stuck using virtual machines. So before I get into the how, let me first talk about the why. There's a bunch of reasons why you might want to virtualize macOS instead of running directly on the bare metal hardware. First, you're going to simplify your life a lot. By creating and maintaining 1 or 2 VM templates, you can then scale that out across one Mac or hundreds of Macs by using VMs. This means that you're not re-imaging, patching, updating every machine in your cluster. You just build it once and scale it out using the virtualization technology. Secondly, it's going to be a lot more reliable. Because you can use ephemeral VMs, and that's something we'll talk about more in just a minute, you get the same build every time. Your developers no longer have the "it worked on my machine" problem because every build is exactly the same. You can also track multiple configs. A lot of our customers will maintain separate VM templates for release candidates, debug builds, testing VMs, side projects, other products, etc. And within each of those configurations, you can set different resource allocation, dependencies, build artifacts, etc. Next reason why is scalability. Once you've set up a build cloud that works for 2 VMs, your cloud can scale up to 20 or 2,000 VMs just as easily as your need grows. And if you're working with an infrastructure provider like MacStadium, to scale the underlying hosts is just a ticket away. And finally, once you have everything built in VMs, you can control your infrastructure as code, which allows you to automate everything. Virtualizing your build machines makes it much faster to scale, track, and understand what's really happening. Great, so it makes sense to virtualize macOS. Now what? There's really 2 choices for hypervisor when you're looking at virtualizing macOS. And both are great options, and we've been working with both to give our customers the opportunity to pick what's right for them. If we look at VMware, VMware is probably well known to everybody. It's an established company. It's been around forever. They make super scalable products, and they make products that are flexible and are really designed to do everything, which can be a pro and a con. It can be, you might find workarounds that you have to deploy to actually get it to do a Mac CI cloud. But it comes with a robust developer community. vSphere APIs and plugins mean that you can do almost anything you want with VMware. A second option, and we're excited to be partnered with Anka, partnered with Virtu, actually, the company that makes Anka, as of earlier this year. Anka went GA earlier this year, and they're a brand new hypervisor that is really built for Mac. The setup is super simple because the whole system has been tuned and built from the ground up for Mac CI use cases, which means that their APIs, their command line interface, and their plugins are all built with DevOps teams in mind, and it makes it very easy to set up. They've also got some great features that make their VMs feel a bit more like containers and help you manage a library of VM templates. Now, this may be a little confusing, and that's okay. MacStadium is here to help. These are both great choices, and depending on your company, your use case, one or the other may be a better fit. There's going to be a little bit of work to get either one set up, and MacStadium can help there too. Our experts are happy to walk you through the selection, setup, and tuning of most CI orchestration tools. And we do this all the time with most of our customers, so we've seen all the various ins and outs and can help you make the right decisions. Okay, so we've got our Macs deployed and virtualized. Next comes automation. There are really two ways to think about working with VMs. The first thing that people often try is to use static VMs. These are built once and used over and over. You may or may not revert back or clean up after each build to try to reduce the buildup of artifacts and other cruft that can come up. The other option is to use ephemeral VMs. These are single-use VMs created for each build and destroyed immediately thereafter. Static VMs will eventually break when they get gunked up with build artifacts. And while you can kind of sort of automate fixing them, ephemeral VMs are going to give you a much more consistent and immutable build environment. So how do you actually go about doing this automation? Once you've moved into a VMware or an Anka-based VM on your Macs, once those Macs are deployed in a scalable cloud infrastructure, you can start using plugins and APIs to really do most of this. Both hypervisor layers will provide hooks into CI orchestration tools and infrastructure as code tools. They also have direct hooks into their APIs that let you specify your build pipeline in code and then update that code. This helps you create consistent builds. It eliminates human error. It removes the every other week process of patching and updating Macs. It adds redundancy so that individual hardware failures won't slow down your team. And of course, once it's all built and automated, it's going to scale up much more easily. And while it does take a little bit of work to get this going, teams that make the investment never look back. Their builds go faster. They can focus on solving other parts of the problem. And it's really, we only hear exclusively ecstatic feedback from people once they've actually gotten this set up. Okay, now that it's all set up, we're going to talk about how to speed up those builds. So there's a bunch of ways that you can speed up builds. You can refactor your code. If you put in the work to make everything explicit, use faster libraries, pre-compile your build artifacts, etc., it's going to help, but it's really hard. It takes a long time, and usually it's hard to find the time to pay back that tech debt. Another slightly faster option is to parallelize your builds and your tests. Now, this can be akin to refactoring. You may need to rewrite or restructure your app to make sure that it can be parallelized. You may need to think about your tests in a different way. But parallelization can offer big speedups, especially when you're on multi-core build nodes. Another option is to preload your code repositories. Some of our customers do this. They use a Packer script to push their entire Git repo into the VM image every hour. This means that in between those hours, when a new build is run, it doesn't have to download the full Git repo to get started. It will just take a single small diff to get up to date from what the last time that the repo was pushed into the VM template and get off and running. Depending on the size of your code base, this could save you minutes per build. There's also some great tweaks to Xcode, and using bigger builders will always help. And those two are a little bit simpler, and we can make some more general statements about how that works. So I'll dive into each of these in a bit more detail. First of all, looking at tweaks for faster builds. So if we think about Xcode as a bit of a highway running your builds, increasing the thread count is akin to increasing the number of lanes on that highway. Now, Xcode will by default give you a number of threads that matches the number of cores on the build machine that you're running on. But because most cores are hyper-threaded, and because parallelization can be of value even if you have more threads than you have cores, manually upping this number can dramatically improve your build times. The second option is to increase the number of concurrent build tasks. Now, again, if we're talking about the highway metaphor, this is like adding more cars. First you add lanes, then you add more cars. Each of these concurrent build tasks means that you're splitting out pieces of code that can be built in parallel. Certain languages and certain code bases are going to be more readily optimized by enabling this option. And the third thing is to set Xcode to optimize for performance gains. This is, to use our highway metaphor, a bit like taking all the seats and the air conditioners out of the cars so they go faster. Some of the things you'll trade off are potentially speed of execution once you're finally done with the build, and the ability to debug more robustly. But if this is part of a CI process and you're pretty sure that this code is going to compile because your developers have written it and are committing that code back to trunk, you may not need all of the robust debug features, and pulling them out might speed your build times up quite a bit. The final thing on this list is to turn on your build time summaries. So this is a way that if you've enabled some of these quick tweaks and you're not seeing the build speeds you want, you may want to look at the build time summaries to see where your code is actually taking the most time to build. And that can take you back to refactoring, but at least you'll know where to start your refactoring to get the biggest bang for your buck. Secondly, on the side of testing, this is another place where CI pipelines can spend a lot of time. By default, the iOS simulator in Xcode will run full pixel, full frame rate renders of your app. Now, that's great if you're looking at it as you test out different features and seeing how good it looks and understanding the full UX. But if you're just burning through some integration tests on a server sitting at MacStadium that's not even connected to a monitor, you're crushing your GPU and slowing down your CI pipeline for no reason. So you can tweak the iOS simulator pixel size to be much lower than the full Retina display that's displayed on your phone. You can change the simulator rendering mode so that it's not really using much GPU as it moves through the motions. And that'll save you some time as well. Now, this next part is the easiest one of all. More cores make your builds go faster. So this was actually some benchmarking that one of our customers sent to us, looking at how the build time varies based on the number of cores allocated to the build VM. So keep in mind that everyone's results are going to be slightly different based on your exact code base, but they found that using 4 cores instead of 2 went 1.6 times faster, and using all 12 cores in a 12-core Mac Pro with Anka as the hypervisor layer had them going 2.6 times faster. Now that's a pretty simple tweak, and you can work to understand the trade-offs there, and you should experiment to find the optimal VM size for your team, your app, and your budget. But the ability to change a single setting and get a 2.x speed up is pretty profound. Now, this one is my favorite. And it may not be a surprise to you, but faster Macs also go faster. So we've done a bunch of benchmarking with different Macs to see how much difference that really makes to build times. And we tested a 2-core Mac Mini, a 4-core Mac Mini, a 6-core Mac Pro, a 12-core Mac Pro, and even an 18-core iMac Pro, which Apple calls the fastest Mac ever made. When we ran those experiments, this is what we got. Now, 100 minutes to compile the Swift C++ compiler on a 2-core Mac Mini is quite a long time. But you can get a 7.7x speed up by doing nothing but changing the underlying build machine. Now, I think that that is a testament to the difference between a computer that's released this year and a computer that's released almost 8 years ago in the case of the Mac Mini. So we've touched on how to deploy, how to virtualize, how to automate, and how to accelerate your iOS and Mac app CI pipeline. I hope that you've learned something, and we've got a few more minutes here for any questions from the audience. Jana, how's our question queue looking?
So one of the questions is, why don't AWS, Azure, or Google offer this service?
As I said, I think that there's a couple of reasons. The first is that it's actually really difficult to work with Macs. We've spent a lot of time at MacStadium building up the expertise around it. We've designed and patented custom hardware and custom configurations that allow us to do this more efficiently. We actually manufacture our own sleds to rack them. We manufacture custom upgrade kits to help us get the right I/O ports so that they look and act like enterprise servers. And that's not easy to do. So when these big companies can make so much more money racking thousands of little Linux toasters, probably millions, there's just not the incentive for them to do this extra work to make Mac infrastructure available.
All right, the next question is, does virtualization reduce the build speed?
Yeah, that's a great question. Virtualization will almost always reduce the performance of a workload running in a virtualized machine. Now, that makes sense because a VM has to do a little bit of extra work to exist as a virtual machine, whereas something running on a bare metal computer doesn't have to pay that extra virtualization tax, as some people call it. However, what we see is that if you do these, some of these tweaks, you can actually get performance that's pretty comparable to the bare metal performance. And furthermore, the small virtualization tax that you might pay is far outweighed by the benefits of automation, reliability, and scalability.
The next question is, what extra setup do we need in our Jenkins master to connect it to MacStadium?
So to connect a Jenkins master to MacStadium is really straightforward. If you're using VMware or Enka, there are plugins that can do most of the hard work for you. And the real trick is really just creating an IPsec tunnel between MacStadium and wherever your Jenkins master lives. So a lot of customers will put their Jenkins master on AWS. Some people will have it on in-house infrastructure. And because every MacStadium environment is deployed as a private cloud and sits behind a dedicated firewall, you can create a VPN tunnel between the firewall at MacStadium and whatever environment your Jenkins master is sitting in, and the plugins can do the rest.
Does Enka hypervisor run on top of macOS, or is it installed directly into Mac hardware?
Yeah, great question. The Enka hypervisor is run via an agent that lives directly on macOS. So the base operating system when using Enka is macOS. The base operating system when using VMware is their ESXi operating system. Because Enka runs on macOS, it actually means that Enka is more likely to support new versions of macOS when they launch, and it allows Enka to work on more types of Mac hardware, including the Mac Mini, the Mac Pro, and the iMac Pro.
Okay. And what is the ballpark cost to bring in a Mac Pro into a build farm, and what is the minimum time that people tend to see provision additional capacity before they release it back to MacStadium?
Yeah, great question. So in terms of specific pricing, you can look on our website at macstadium.com and see some rough pricing for different types of clouds. The question on how long people typically hold hardware before releasing it back to MacStadium, because we deploy private clouds, we are not able to do what public cloud providers do, which is sort of rent VMs by the second or by the hour. So we will deploy hardware for a month at a time, and customers typically, once they've expanded their capacity to support their full development team, we actually typically see customers only continue to grow, which is almost always the case. You're not going to typically need less infrastructure in the future than you need today. Sometimes customers will let us know if they think they're going to have a big batch of additional builds because they're running up against a big release deadline, and they may add some additional infrastructure for just 1 or 2 months to deal with that excess need.
Now, when you're talking about recommending VMware, do you mean specifically VMware Fusion or ESX?
Yeah, great question. I didn't touch on VMware Fusion here. VMware Fusion and VirtualBox are sort of consumer-grade tools. The performance that you're going to get, the scalability, and the security features are just not quite the same as what you're going to get with VMware Enterprise. So that's what we deploy for all of our private clouds. VMware Enterprise runs on top of ESXi, and it allows you to do really interesting things from a security perspective, as well as getting access to linked clones, and in the new version of VMware, a feature called instant clones, which starts to be able to deploy VMs that look and act much more like containers. You can also, when using VMware Enterprise, do things like dynamic resource scheduling and high availability configurations, which make your infrastructure much more available and redundant. So I think that that's almost it for time. I wanted to thank everybody for the great questions, first of all, and thanks for your attention throughout the presentation. We do have some other resources if you'd like to keep learning about MacStadium or iOS CI. Check out our knowledge base at help.macstadium.com. Sign up for our newsletter, macstadium.com/newsletter. And for this audience, I think you'll be interested in an iOS DevOps survey that we did when we were out at WWDC recently. You can find it at the URL here. Take a look, it's pretty interesting. And if you'd like to participate, there's a link at the bottom. We'll be sure to have more webinars coming out in the next couple of months. Get in touch if you have ideas on topics that you'd like to hear covered. And until then, talk to you soon.